Hi everybody. Sorry that I can't be in class today. Rhett had a fever when we got home from school, so I have to stay home with him. But I thought I'd make a video that I could post and you all can watch it, and so then you won't be so lost with what you're trying to do at school. So we're still talking about linear equations in standard form. The example we did in class today was about the amusement park and the different ticket numbers and how many rides she could go on if she had 24 tickets. So we're gonna do two different word problems, setting up the equation and then looking at what the graph looks like. And then I'll do a couple of examples of if you just had the equation and you were asked to graph it or find the x-intercepts, what that looks like. So there may be multiple parts to this video. So the first one is about Gary. He's gonna make punch to serve at a party. It calls for mixing lemon lime soda and cranberry apple juice in no particular ratio. He can buy lemon lime soda for $1 per liter. So we'll use L for lemon, and that's $1 per liter. And he can buy cranberry apple juice for $1.50 per liter. All right, he wants to spend exactly $9. And so the question is asking us to write an equation and then figure out the different amounts he could buy of each. So the way that we're gonna set this up is we're gonna let X be the amount of liters of lemon lime soda he buys. And then we'll let Y be the number of liters of cranberry apple juice. All right, so what we know is that it's $1 per liter of the soda. So if you bought 1 liter, it would cost $1. If you bought 2 liters, it would cost $2, etc. So for each liter of the lemon lime soda, it's gonna cost him $1. And then we know that the cranberry apple juice is in $1.50 per liter. So 1 liter would be $1.50, 2 liters is $3, 3 liters would be $4.50, etc. And so we're trying to figure out how many of each he can buy if the total is gonna be $9. So $1 per liter of lemon lime soda plus $1.50 per liter of the cranberry apple juice. Altogether, we want to spend $9. So because there are two variables here, we could rearrange the equation to solve one for the other, but we can't just solve for one and get a number answer. So that's why there's multiple different answers to these types of problems. So the easiest thing to do is say, well, this wouldn't really be a punch, but what if he just bought none of one of the things? So if he bought none of the lemon lime soda, that would be a 0. So the X value would be a 0. So I'm gonna write that over here. And so we would have 1 times 0 plus 150y equals 9. And so 1 times 0 is just 0. So that makes the equation 150y equals 9. We could divide by $1.50 on both sides, and we would get that y would equal 6. So if he bought 0 of the lemon lime soda, he could buy 6 liters of the cranberry apple juice, which would not be a punch, it would just be the juice. All right, but that could be an ordered pair. So the other thing that could happen is he could buy none of the cranberry apple juice and only buy the lemon lime soda. So the equation for that, you can probably already figure it out, but the equation would look like 1x plus, he's not gonna buy any of the cranberry apple juice, so he's buying 0 of them. And how many could we buy for $9? So obviously 150 times 0 is going to be 0, which means 1x equals 9, which means that x must also equal 9. So that option is saying we bought 9 liters of lemon lime soda and no liters of the cranberry apple juice. Again, that would not be a punch, that would just be lemon lime soda. But it's given us an idea about what this graph is going to look like. Another thing you may want to take into account would be, well, what if we bought 3 liters? Notice that because this is 1.5, we have to buy 2 of them in order to get an even number, in order to get $9. So maybe we buy 2 of these, so we could figure that out. So if I bought 2 of the apple juice, we want to figure out how many of the lemon lime sodas we would have. So 1x plus 1.5 times 2, meaning we're buying 2 of them. Well, 1.5 times 2 is 3. So 1x plus 3 equals 9. Minus 3 from both sides. X would equal 6. So that ordered pair would mean we purchased 2 of the cranberry apple juice, so that would be our Y, and our X we said was 6. So when we write that as an ordered pair, it looks like that. Maybe also we want to take into account, what if we bought 4 of the lemon lime sodas? So 1x plus 1.5 times 4 equals 9. Excuse me. So 1.5 times 4 is going to be 6. 1x plus 6 has to equal 9. So if we subtract 6 from both sides, we would get that x equals 3. So again, that ordered pair would mean we bought 3 of the lemon lime sodas and 4 of the four of the cranberry apple sodas or juice. Okay, so we've got 4 ordered pairs here that represents different amounts of cranberry apple juice and lemon lime soda. So what we're gonna do now is we're gonna graph this so we can get an idea of what all this means. So this is just a rough sketch, it's not gonna be perfect. So my X values we said was up here. We said that's our lemon lime soda. I'm just gonna write soda. And then our Y then are liters. This is in liters. And then our Y is our juice, cranberry apple juice. Again, in liters. All right, so looking at our points, the biggest number we have is 9. So I'm just gonna count by 2s, I think, in all directions. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Okay, should maybe label that. All right, so the 4 ordered pairs we have to graph are 0, 6. 9, 0. So those are our 2 intercepts. That's our x-intercept and our y-intercept. 6, 2. And 3, 4. And as you can see, it is a rough sketch, but as you can see, those points do in fact make a line. So if you were able to buy liters of soda or liters of juice in partial amounts, then you would be able to create any of these different options for soda and juice in order to add up to $9 total.